So let's begin. A ball is falling vertically with speed u when it strikes a smooth plane inclined at an angle a to the horizontal. If the coefficient of restitution is a quarter, find the lengths of the first and second hop. So it seems to be a very abstract question. What I mean by abstract question is that it's not really giving us any specific numbers to work with really, bar the quarter. Okay, so what we're going to do is we will it's falling vertically, means it falls this direction here. I'm then going to continue this line straight down, and I'll explain why I'm going to do that now. That's A, that's 90 minus A. That in turn makes this 90 minus A, which in turn makes that 90, which in turn makes that A. Alright? So basically I can now just rub out the other parts and just say, well look, this triangle here is this triangle here. I can break it up into its cos and sine. Okay, so speed u when it strikes a smooth inclined plane. Alright, so there we go. So this is going down and across, so that is going to be minus u cos A. Why is it minus u cos A? We're assuming going downwards means you're negative and going upwards means you're positive. This is going to be u sine A. This is the other one. Okay, so that's your speed. Okay, as when it strikes. So that's your speed just before impact lands. Okay, that's your speed just before impact. Okay, so now we have to find the impact after collision. We know that E equals. Sorry. E equals a quarter. Okay. Now, what we're going to get next is, guys, we're going to have to break it up into its. Components. Now, which is the only component that's affected by the collision? The u cos alpha is the one that's affected by the collision. So it's gonna come on its way out. Okay, so it says find the lengths of the first and second hops. Okay, so that's going to take a bit of effort. So after the first hop, okay, so first hop, initial speed. How do you spell hop? H-O-P. Initial speed. Okay, so initial velocity even. Okay, so initial velocity is going to be, it reverses direction and it's on its way back this way. So when it's on its way back this way, the u sine A stays the same, and it's going to be a quarter cos A. Where do I get a quarter cos A from? A quarter u cos A. Where do I get that from? Change its direction and 1/4 of what it was. Okay, so your velocity this way now is going to be technically it's u sine A along the plane. Okay, and what way do we do this? We call it phi x and phi y. So that's technically ux, and this one here, uy, is a quarter u cos A. Now, once we've done that, guys, what we're going to do is we're going to set up our formula. What happens now when this happens is that gravity takes its effect and starts to bring it back down again. Do you understand that? And we're also assuming that, see the triangle I drew, we're also assuming that the triangle I drew here isn't quite sufficient. Like it's actually, that's the first hop, and then the second hop will be a bit shallower again after that. Is everybody alright with that? Just didn't make the triangle long enough. Okay, now that's taken care of. What we're going to say is that after the first hop, your ux is going to be, what's ux? Ux is along the x-axis, so it's going to be u sine A. And uy is the initial velocity after the bounce along the y-axis. The quarter cos A. Quarter u cos A. Keep forgetting the u. Keep an eye on that. Now, what do you mean by lengths, guys? What does it mean by length? So we're talking about this length here. See the big red length there? That's the first one. And then the second one is going to be the green one. What is that? Is it an SX or an SY? It's SX at TOF. And how do you find the TOF? SY equals 0. So long story short, make phi x, make phi y, make SX, make SY. So we're going to go through our procedure. Okay, ready? Phi equals U plus AT. S equals UT plus a half AT squared. Let's have a look. Okay, phi of x equals U sine A. Now, is there any deceleration going on? It's an inclined plane, which means there is accelerations going on. Okay, we have to do our gravity triangle. We haven't done that yet today. So I'm just going to rub out the initial one. Now, our gravity triangle. Anybody remember to do a gravity triangle? It's coming straight down, and then you resolve it parallel and perpendicular to the plane. There's an acceleration causing it to go faster down the hill. Yeah. Going this direction, and there's acceleration driving it in. So that's your G there, your G going directly down. Your angle A, as we've always done, okay? What is this component here? G cos A, and the other component? G sin A. G cos A, G sin A. Okay? So G cos A is going directly down, G sin A directly to the right. So what is this then? Going to the right is going to be GT sin A. What about phi y? U cos A, U over 4 cos A. Yeah. And what's the gravity? Is it working against it or for it? Against, because you're on your way up and you're working against gravity. Okay, so you're on your way up, you're working against gravity. So it's going to be minus GT cos A. Because cos A is the part that's going directly down. Okay, how do you change a phi x into an SX? Anybody remember? Add a t and half the second one and add another t. Okay, what about SY? U over 4, UT over 4 cos A, and then minus a half GT squared, so just GT squared cos A over, what was it? 2. Okay, let's roll with this. SX, SY equals 0 first, right? For the range. So SY equals 0, what would that mean? If that equals 0. Bring that over to the other side, and what you're going to get is UT cos A all over 4 equals GT squared cos A all over 2. Now the angles are reasonably nice here, aren't they? Because they're going to cancel each other out for once. Just for this question, I would say the t cancels with the other t. And then we're going to have 2u over 4. I'll just cancel that into a 2 and cancel that into a 1. What'd you say? We didn't get rid of the u. So t equals u over 2g. Is that what you said? Okay, sorry, my bad. Okay, t equals u over 2g. Now guys, what we're going to get next is we got to plug that into SX, okay? So SX is going to be u times t, which is u over 2g. Then it's going to be sine A. And then it's going to be plus gt squared. So g, now what's t squared? If that's t, what's t squared? U squared over 4g squared. Okay, so just change it before you even get in. And what am I doing after that? Sine A, and then all over 2. Let's have a good look at this, okay? Sx is u squared sine A all over 2g. Now, the other one is multiply the 2 by the 4g squared to get 8g squared. Then leave it as a u squared g sine alpha on top. Modify it by getting rid of the g on the top. The g on the top with the squared on the bottom. Give them the same denominator would imply 8g, right? So you're going to multiply this one by 4 on top and bottom. And now I have an 8g denominator. 4u squared plus u squared sine alpha. 5u squared sine alpha all over 8g. And that's the range of the first bounce. So, we got the length of the first bounce, which is great. However, there's a problem. Here's the problem. The problem is we have to find our phi x and our phi y just before collision, because we then have to calculate the rebound velocity after that. So we're going to have to get phi x and phi y at the time of flight. So now that we've universally accepted this answer, and this answer has nothing left to play in the entire question, we can just get rid of it. And we can go, wait a second. There it is there. Our time of flight. We need our time of flight still. Now, we're going to put our time of flight into phi x and phi y. So, once again, still I'll need that. And just circle this. This time of flight business here is the most important piece of information we have. Now, what we're going to do next is we're going to look at phi x and phi y and put in our time of flight. Phi x is going to be equal to u sine alpha plus g times t sine alpha. Anybody want to tell me what phi x is then? It's going to be 3 over 2u. Is that right? U sine alpha plus u over 2 sine alpha will give me a phi x value of 3 over 2u sine alpha, 1.5 basically. Okay, once we're done with that, we're now going to find phi y, which I'll do in green. Phi y equals u over 4 cos alpha, and then minus gt, so it's going to be minus g times t, which is u over 2g cos alpha. Are we expecting this to be positive or negative, lads? It's the phi y just before the second impact. Look at your diagram. Expecting phi y to be going down or up? Expecting to be going down. You're a genius, right? Now, what we're going to have here is that it's a good feeling when you know it's meant to be negative, and it is negative. Okay, you know you're more than likely still on the right path. If it's a positive, you know you've gone wrong somewhere. You need to have a look right away. They cancel. U over 4 minus u over 2. Same as a quarter minus a half. Minus a quarter. So there's your new phi y and your new phi x. So phi x and phi y just before impact. Phi x is 3 over 2 u sine alpha, and phi y is minus u over 4 cos alpha. Now guys, let's look at this again. Okay, we are just before impact. We're coming in, we're hitting off, and we're coming back out again. Currently speaking, we're on the second hop, which means that this is phi x is 3 over 2 sine alpha, and that is minus u over 4 cos alpha. Which one's affected by the bounce again? On the way out is now in red. Which one's affected by the bounce? This one here, this component here is affected. How is it affected? It's a quarter of what it was in the opposite direction. So it's going to be u over 16 cos A. And this one here is still 3 over 2 sine A. Now once you figure that out, what we can do next is you can do a bit of recycling. Okay, now what I mean by recycling is you just grab what you've already used before, you group it, and you drag it down here, okay? Well, you rewrite them. much easier. Now, we go back down here, and what I'm going to do is I'm just going to modify my old equations to suit the new equations. So, my phi x is now changing to 3 over 2. Second part remains the same. 3 over 2, second part remains the same. Next thing you're going to do is turn that 4 into a 16. And you can see you don't have to go through the whole building blocks again, don't need to be done. You just need a slight modification, saves yourself a lot of time. Okay, and that there, 16. Everybody alright with that? Now we're going to find the Sx, because it only wants the length of the second bounce. Do we need to find phi x and phi y at the end here? Can anybody tell me? Why not? Because it only asks you for the length of the second bounce. So we had to find phi x and phi y at the first bounce to calculate our starting velocities at the start of the second bounce. That's the only reason we had to do it. Okay? Yes, Tom?
On these ones, can you still find t using Vy?
Phi y, no, when phi y equals 0, it will be the maximum height of the bounce. Oh, and double it,
yeah.
as in it's symmetrical.
Yeah.
I'll tell you what, I'll do sy equals 0.
Yeah.
Then I'll do phi y equals 0 and see if it's exactly half it. We'll just test it out. Okay. I think it's still symmetrical, so it should be okay. We'll verify it though. Okay. Now, what we'll do here is sy equals 0. When sy equals 0, what you're going to get is ut over 16 cos alpha equals gt squared cos alpha over 2. Cos alpha's cancel. The 2 cancels with that 2 there. And we're going to get I'll just bring the 2 up there. 2u over 16 g equals t. And then the 2 over 16 turns into 1 over 8. So u over 8g. Okay, it's the time of flight. Now we're going to test out Tom's theory of phi y equal to 0. If phi y equals 0, we're going to have u over 16. What's it? U over 16 cos a equals gt cos a. Cos a cancels. And then t is going to be u over 16g. Exactly half of the other one. So it still holds true because the flight is symmetrical. So when your phi y equals 0, the time it takes that to happen is the same as half the time of sy equals 0. So you can get phi y equals 0 and double your answer to get your time of flight if you want. Still working. Okay? Now that we've got that done, what we're going to do is find out what Sx is, or the range. So let's find out what Sx is. Oh, sorry, I wrote that the wrong one, didn't I? It's over 8g, not over 16, so 8g. That's our time of flight. So time of flight goes up here. And there's my equation, Sx. Sx equals 3 over 2u multiplied by t, which is u over 8g, plus gt squared, so g over 2, t squared being u squared over 64, g squared sine a, because if t is that, t squared is u squared over 64g squared. Now, look down at this, Sx equals 3, am I forgetting to sine alpha? Forgot to sine alpha. So 3 u squared sine alpha all over 16 minus, or sorry, plus you what? Ah, thank you. 128g on the bottom, and u squared. What we have here is 128g, because that g will interact with that g there. And then we have u squared sine alpha. Now, they are not the same fraction. It goes in 8 times, right? 8 16s are 128. Multiply by 8, top and bottom. When you multiply by 8, top and bottom, what you're going to get instead of that is you're going to get 24 over 108. 24u squared over 128g. Add them together, you get 25u squared over 128g as your SX. What did I do wrong? Sine. There we go. That took